Good evening, dear students. We started the subject that is data structures using Java. Data structures using Java. This is the subject. The subject. Now, in this, we have started the basic concepts. Start basic concepts. The basic concepts were what is algorithm? Just to see what is an algorithm, what is time complexity, what is space complexity. Uh, the basics we started. So what did we yesterday class? What were we started? To the continuation to that, to the continuation to that, yeah, in the mathematical review and analysis about what is become what is an algorithm and its analysis and what is the time complexity, space complexity, this will complete. Now, the year space complexity. Now, what the continuation to that, mathematical notations, what mathematical notations of an algorithm analysis. This we have to discuss. First we have to discuss. Now see the first one is asymptotic notations or you can call mathematical notations. So the efficiency of an algorithm depends on the time. So we have seen earlier the time complexity. So any algorithm efficiency, it depends on the time. If how much time is needed or how much time is required to execute the one program. And next one is storage space, which is dependent on the how much storage is spent on the data. And there are other resources that are required to execute the program for implementing this solver. Now, this efficiency is measured with the help of asymptotic notations. What is the role of these asymptotic notations means? So these are all resources. These are the resources. How they are replacing the memory time these measured exactly measured by these all notations, which are we also call the functions, mathematical functions. So the notations which are used to describe the running time of an algorithm, the input tends towards a particular value or which is limiting the value. So that is asymptotic notation. And next one is asymptotic analysis. The time complexity is expressed, time complexity is expressed as a function of your input size and power of input with the increase in the input size. the performance will change. That is, so the study of change performance of algorithm, that is, order of the input set is defined as an asymptotic analysis. The best case is the size and order of the input, and which will less than and minimum space or least ratio of U is obtained. That's called the best case. Example, you can say, take the bubble chart. The input array is already sorted. The time taken by the algorithm is that is the best case. The worst case is size and order of the inputs at which the average time, an average space, an average ratio of things obtained is called the worst case. For example, when the input array is in reverse condition, the algorithm takes the maximum time of the elements. That is the worst case. The average case. Size and order of size and order of the inputs at most time maximum space rise to ratio of 2 is approximately average case. So why is the asymptotic notations are required? There are two reasons. There are two reasons. So one is we will analyze the time complexity of an algorithm. That is best case, average case, and worst case. We're going to exact step count using the asymptotic notations. Now, even though we come statement of algorithm, later we convert each statement into the asymptotic notations. So there are the three asymptotic notations. There are three mainly asymptotic notations: big O notation, theta notation, and omega notation. There are three asymptotic notations. That is big O notation, theta notation, and omega notation. And two other notations, little O notation is there, and little omega notations, which come in the first and third notations here. So these are the main asymptotic notations, which are main asymptotic notations. These are main asymptotic notations. That is big notation, beta notation, and two other notations. The first one is big notation. First one is big notation. First one is big notation. The function f of n, which is equals to big O of j of n, if and only if there exist two positive constants c and l0, such that the of flows belong of f less than f of n, which is less than c multiplied by, which is less than equal to c multiplied by g of n for all n comma n greater than 0. That is, f of n is equals to 2n plus 3, g of n is equals to 3n, c is equals to 1, and n0 is equals to 3, and then f of n is equals to f of n less than or is equals to c multiplied by g of n for all n greater than or is equals to 0. That means 2n plus 3 less than or equal to 1 multiplied by 3. So for all n greater than or is equal to 3. So there's an example, and this is a verification. So here, when if n is equals to 4, n is equals to 4, f of 4 is equals to 11 we are getting. When g of 4 is equals to 12 we are getting. So therefore, so f of 4 less than or is equals to 1 multiplied by g of 4 when it is equals to 4. So hence for n is equals to 3, 4, 5, 6 is represented simply as for all n greater than or equals to 3. So which make f of n less than or equal to c multiplied g of n holds true. Now we can say that n plus 3 is equals to big of n plus 2n plus 3 less than or equal to 3 for all n greater than or equal. So based on the above discussion, we can take many examples of notations. Many examples we can take for the big notation. So that is so 100n plus 8 is equals to big of n as 100n plus 8 less than or equal to 1 at 1 and for all n greater than or equal to 8. So like this, we can say that, so if f of n is equals to n for n plus so on like this, we go for n for n. That means the highest exponent in the function f of n will become the equal of n. Now equal notation represent the upper bound of the running time of algorithm, and it gives the worst case complexity of algorithm for any value of the running time of an algorithm does not pass time followed by virtual, since it gives the worst case running time of an algorithm. It is widely used to analyze an algorithm as we are always interested in the worst case scenarios. These worst case scenarios. So the following table shows that ascending order of time complexity along with their mathematical behavior. The mathematical behavior, the ascending order of the computing times. That is, we got one constant and log n, so logarithm. We got n, it is linear, and we got the n log n, linear logarithm. And we got n square, it's quadratic. We got n cube, it is cubic. We got 2 power n, it is exponential. So execution time or runtime of an algorithm is from big of 1 to big of 1. This is theta notation. The example you can see theta notation. So when f of n is equals to f of n is equals to 2n plus 3, a of n is equals to n, c1 is equals to 3, c2 is equals to 3. This is then 2n plus 3 is theta fn as it holds c1 g of n t less than or equal to f of n. So this verification process, this is a verification process. The next one is omega notation. And the example for this, let's take 9n squared plus 5n plus 6, which is equals to omega of n squared as. So just like Pico notation, in omega notation also there are several geometries which holds f of n is equals to c multiply g of n. But we pick lower bound of g of n is, so once for any value of n, the minimum time needed by the algorithm, a program is given by omega, we used to represent the best case analysis. So little one notation. So that means that PU f of n is equals to O of g of n if and only limit f of n is equals to 0. So example for this, this one, f of n is equals to 2n plus 3 and g of n is equals to this one. So when you analyze the time complexity from step count tables in asymptotic notations, so these are the statements. The frequency, and the total number of steps. The statements, frequency, total number of steps. So from above that, what is asymptotic notation? Asymptotic analysis. So right here. So other parameters of performance measurements are the time complexity generally depends on the instance, such as compiler tools, etc. The time complexity depends on the instances, that is the type of machine compiler and the tools, etc. So this will enable to express time variation of algorithm based on instance characteristics. It's compared to algorithms P1 and P2. So solves the same problem. The P1 takes the time big of n, P2 takes the big of n square. So then P1 is faster than P2 for certain large value of n. The of n is equals to big of n, and only there exist two positive constants C1. And such that f of n is equal, of n less than or is equal to C of C1, and for all n is equals to 1. So here the performance measurement contains two phases, as we mentioned earlier. Now this process will take space and time requirement of an algorithm. The time and space requirements depends on compiler time, computer on which the computer runs. So this is log n and log n square into the 4n. So but we ignore the compile time in performance measurement as a program is compiled once and run many times. The compile time is space time consumed for compilation is considered in next phase. That is testing phase. So when compilation time more than runtime, this would be considered in performance measurement. In performance analysis phase, in order to analyze the performance of program, first we have to decide on values of for which we gather the time of take the values of what the worst case is analyzed. So in the performance analysis phase, open the run, we need to experiment. So what's the accuracy of the computer? Well, how accurate the results are going to be. Once we find out this, the shortest limit to the time. So finding the repetition factor of each instance size will be minimum time, minimum event within accuracy. Whether we are analyzing the worst case or average case, based on this, we can find the suitable test data. So what is the purpose of the experiment? Comparison purpose or prediction purpose. So the prediction of runtimes when we need to fit the curve using the asymptotic analysis. That is asymptotic complexity is linear. So test data generation phase. The data set that is to be used to test the algorithm contains instance characteristics generated using various methods, such as computer program, specific application and algorithm. So why do you need the instance characteristics? The question we likely found out about. So in summary, so an algorithm is a precise rule or set of rules specifying how to solve some problem. The summary of the first unit is, so what is an algorithm? So the algorithm is set of rules that we understood specifying how to solve some problem. So though there are no standards for writing algorithms, generally it is written in start and stop steps. Some may start with the definition of algorithm in the like that. And the space complexity is nothing but computing the space and like program memory and that number stored. And this process includes various aspects of the program as part of space, like whereby it's a part of the program. And this part includes the space like the program instructions. The variables instances. Space occupied by the first fixed part is independent of the number and the size of the code. That the variable that means independent of behavior of the program. The space consumed by the variable part of the program. So how much space is occupied by those variables? This part includes the space consumed by the reference variables, which also dynamic and size values. Recursion stack and input code depends on the behavior and external factors. A theta notation includes the function from the upper bound and lower bound. And lower bound and the runtime of lower bound. So when data set is generated, in the test worst case analysis, always select the test data that produces minimum from times of lower bound for instance characteristics at the same power. So this is a overall summary of the first unit topic. So you can check your progress with this. Then you check the model examinations. These are all some basic vocabulary what we discussed in this subject. The next unit is stack data structures. Next unit is stack data structure. Now, as part of this, we will understand what is the interaction of the stack ability model, implementation of the stack, applications of the stack. This will understand. Stack is an abstract data type. It's commonly used in most programming languages. Likewise, stack ability, that is abstract data type, which allow all data operations at one and only. At any one given time, can only access the top element of the stack. Yeah, if you want, you can see here, this is the this is the box from here. These are the elements. So what stack does is it always picks the top element of the stack. Always picks the top elements of the stack. Like this. So this feature is it's known as last in first out data structure. Once this is last in first out data structure. This concept is known as this is a abstract data type ADT. It is a type or a class and whose behavior is defined by a set of values and set of operations. There are some set of values are stored under the variables and the set of operations used to apply on those values. Or you can say variables. There is the definition ADT mentions what operations are to be performed, but not how these operations will be implemented. So what an abstract data does is, so what the operations to be performed it does. It's not how those operations are implemented. So this is what this is what the abstract data is about. So it does not specify how data will be organized in memory and what algorithm will be used for implementing the operations. So it's called abstract because it gives an implementation dependent process. Now this process of providing only the essential and adding the details is known as abstraction. The stack operations are empty, push, on top, these four. These are the functions, operations, with the functions used to apply those values. Stack ADT and its model. You can see abstraction. Exactly the abstraction is about this. It refers anything hiding the client from the implementation details. That's the abstraction. So if you take any vehicle, the vehicle internal components will be hidden from the driver. The vehicle internal components will be hidden from the driver. And so this vehicle, this vehicle internal components are so many. These components, the driver cannot see. Okay, first abstraction is. So abstraction, the implementation details will be hidden from the user. So the entire working of computer is abstraction because you can't see anything inside. circuitry of neural. So abstraction, you can understand that anything we cannot, everything we cannot see from the object. You can say everything is an object. You take a vehicle is an object. The vehicle internal components or internal mechanism, it's a design, working process we cannot see. Only will understand that how it is, how to use that. To understand is how to use that. So that is an abstraction is. So here the data type is set or for operations on the data which is required. So what is abstract data type is data type here is for set of operations on the data which is and is the abstract data type is the specification of data type or data structure independent of an implementation. The interface for the abstract data type is defined in terms of type and set of operations and the type. So the behavior of each operation is determined by its inputs and outputs. An abstract data type does not specify how the data type is implemented. And these implementation details are hidden from the user of the abstract data type and protected from outside access. So in Java, the abstract data type is just like an abstract class. Generally, the type in the abstract data type called as fields are data holders in the operations are called as behavior. The data structure is the implementation of for an ADT, taking operations on the data language. The object-oriented language, an abstract data type, and its implementation together make up a class. Each operation is associated with the ADT is implemented by the member function or method. So the variable that define the space required by a data item are referred to as data modules. A stack contains a sequence of items that are inserted. You can also call push. Remove this called path. Remove we can call path and insert we can call push. So according to the last in first out leaf order, first in last order. So an item can be inserted into a stack at any time, but the only access or the most recently inserted, right? But remains top of the stack. The name stack is derived from the stack of plates in spring loaded affiliate plates. In this case, fundamental operations involve pushing plates in this stack. When we need a new plate from the dispenser, we have the top plate of the stack and we will add a plate, we push it down the stack to the new plate. Next editor, in a text editor like in a Word or WordPad, the new operation rewards the actions in the last and first order. That will be the most recent action from past. Recent documents display the recently the documents in the leaf order. Now the stack functions are, let's say the stack functions here. Push is a function, top, is empty, is full, size. These are all functions. These are all functions. Now attributes. Now what is the push means here? See the operations we are understanding. Insert an item into the stack. Insert an item into the stack. Okay, this is stack. We are inserting the items. We are inserting the item. This is called push. This is called push. Pop means removing, like this, removing. This one will be removing. This is called pop. This is called pop. Next one is the top. So here, you get to retrieve the top item of the stack. Which is the top item of the stack. That means this is the stack which contains all these elements. Copying this item will be retrieved. Each access, we can say the access. Access. And now is empty, returns true if stack is empty. Now is full, returns true, the stack is full. In size, return the size of the stack. So these are all the functions applied on these, the stack of elements. There are functions applied on the stack of elements. The property of the stack is the stack is an order list of similar data type. The stack is LIFO, last in first out structure, or we can say first last out. Both insertion and removal are allowed if only one end of stack problem. The stack is said to be in overflow state when completely full, and is said to be in underflow state when it's completely empty. So that is stack model. So Java.utilize stack methods with the push, pop, date, empty, and the size. Implementing stack using the array. As a first implementation of stack ADT, store elements in an array name, the size of it, we push the items into the stack so that the first item goes to the bottom of the stack. Let us say like this. This is a stack. Now we are pushing the first stack, it will go to the bottom of the stack. The top element of the say first item, this is the first item, the item number one. First item goes to the bottom of the stack always. This is the bottom of the stack. Okay. This is the bottom of the stack. Now index bottom of the item is A0. The top element of the stack cell is A top. So index that equals to 1 less than the current size of the stack. So when we apply the push item, we first increment the operation by 1 and then push the element at the top. Now as pop, we look at the top element of the increment top element. So that is the top is equals to top minus 1. Then the stack is empty. Pop retrieves the items as long as the stack is not empty. So it is So you can see this Java program. This is a file name .java. So this is a class. The modifier is public. This class can be accessed in anywhere in the package. Anywhere in the package. And the public static final increments is equals to fine. The constant is final. The value cannot be changed. The constant error value cannot be changed. We are declaring the array size here, array with the integer values. And we are using the variable top. And here we are defining the array style function. Array style function. So with that, here the push operation we are performing. That is, we are pushing the values. Now here we are checking the condition that the top element is less than max or no. Let's say top is equals to 2, the max is on shear point. So it must be less than or is equals to the top always must be less than max. If the top is 6, let us say if the top is 6, the max is already 5, then this condition gets failed. This condition gets failed. So array of top is equals to number. If the condition wanted to be 2, here as the top is 2, the max is 5. So 2 less than 5, the condition is it will come to this line, the statement, and this statement, and this statement. All these statements will be executed. That is the array of top. Whatever the element is there comes here. Array of 2 is equals to number. And that will be displayed. The number will be displayed. And the top will be incremental. That means the 2 will become 3. The 2 will become 3, 1. So which is a post increment. So 2 plus 1 is 3. Else, so it display stack full cannot add value. If the condition fails, if this condition fails, it will display this else block. Display the else block. In the public int of operation, and here top minus means if top less than 0, it will execute this part, else execute this part. And after this is a main method. Always program starts from the main method. Always program starts from the main method. So that is array stack S1 is equals to new array stack. Here an object will be created, and here second object will be created. Second object will be created. And push one and push three. Here we are pushing the values into the stack. We are pushing 1 year, we are pushing 3 year, pushing 5 year, 7 year, and here 9. So stack clear. End of the stack, push 11. So here we get another stack overflow. So here we are applying the forward function. So it I is equals to 0, the initial value. So I less than array stack of max. So here we are pushing I multiply by 2 plus here. In the similar way, you can pop the values. You can pop. Once we execute that program, so all these values will be pushed to the stack to an attack value. This is pop. So that is so when the stack is creating, so the implementation of stack using the generic array. Where the stack is created using any data type, the data type will be processed as parameter to stack class, which will implement a stack inputs. So the stack first. So this is one program. The other concept is interface. Concept is interface. The next one is stack class extends vector, which implements the listing tupples. Implementing the listing tupples. It's the class. Stack is a class, which extends vector class. Which extends vector class. So that implements the listing tupples. That implements the listing tupples. Now, vector is a resizable collection. It grows size to accommodate new elements and shrinks the size the elements of the model. Now, since the stack class extends a vector, it also grows and shrinks its size as needed. The new elements are added on, removed. So here's our stack class hierarchy. Side variable states collection. The stack extends vector, which does in list, this extends collection. Collection extends side variable. Is an error. That's an error. So reversing the applications of the stack here, the array of elements can be displayed. There's called the reversing array instead. The array of elements can be displayed using generic array implementations of the stack. Let us see one program here. So this is a little package. Java stack. Interface stack interface. Less than. So your checking is empty. So this is what one will show. Now expression conversions for in-phase, post-phase, expressions. So when you write an arithmetic expression such as A multiplied by C, and the form of the expression provides you with information so that you can interpret data. In this case, we know that the variable is being multiplied by the variables. since the multiplication operator appears between them in the expression. Now, this type of notation is referred to as prefix since the operator is in between the two operands. That is probably. Consider another infix example, A plus B multiplied by C. Operators plus and multiplication still appear between the operands. But there is a problem. Which operands do they work on? Does the positive work on A and B? If you multiply to B and C. So the expression seems to be obvious. So in fact, you have been reading this program. So the reason for this, each operator has precedence level. Each operator has precedence level. So operators of higher precedence are used before operators of lower precedence. The only thing that will change the order is the presence of the parenthesis. The precedence order of the other operators places multiplication and division. Above addition and subtraction. Two operators of equal precedence here. And the left to right ordering or associativity. So fixed expression, then prefix expression and postfix expression. These are steps to convert infix to postfix. So this formal program which convert infix to postfix. So this we will understand in next class. So this is a table. Is the program to find prefix to postfix. Then this summary. So this we will understand in the next class. This we will understand in the next class.